Like I just said, we're gonna use these as our notes then for when we do volumes, because we're gonna do volumes of composites as well. Okay. That's fine. Yeah. So what we're looking at here is we're gonna start talking about volumes. Now the difference between surface area and volume is pretty easy. Surface area is what it takes to wrap it up in terms of wrapping paper to go around the objects. Volume is when you fill it full of water. How much does it hold? What's its displacement? Okay. Displacement. That's where you talk about, engine size actually, when you're talking about displacement. You're talking about so many cc's in a motorcycle, cubic centimeters. You're talking about cubic inches on engines. That's the volume that the cylinders hold for the size of where the pistons fit, okay? That's how to determine engine size. That's where displacement comes in. Remember, there's no replacement for displacement.
Okay, can we go on with this? Displacement or debt placement, it really doesn't matter.
Oh my God. It's like this and like that and like this and it's like that and like this and like that and
Like there and there.
There she is, Miss America. Anyway, volumes of prisms. What's happening here is you're just multiplying the 3 dimensions. Volumes go into 3 dimensions. Volumes will be cubes. Volumes will be cubic inches, cubic centimeters, cubic yards, things like that. If you ever bought a bag of mulch, bags of mulch are written in terms of cubic yards. I believe a bag of mulch is 0.5 cubic yards. Does that sound about right? I bought a bunch of mulch last weekend, so. I wish I didn't, but I need more dirt. Anyway, so what happens here is when you're looking at a prism, oh, yeah, so volumes, the volume of a prism is going to be the big B times H. Well, what do you think big B stands for again? Area of the base. Big B is the area of the base. And I don't like to say height. And H is how far apart are the bases. Now, when you're dealing with a prism, remember, the prism are going to be the ones that have exactly 2 of the same bases. Okay? That's how we are able to figure out what that is. Now, if you go back to, if you go back and look at one of our examples from yesterday or the day before, I believe we had, let's skip over the composites real quick. Oh, these are pyramids. Oops. If you go back to one like this, do you agree that that is a rectangular prism? Okay. Rectangular prisms, like we did with surface areas, rectangular prisms are usually the ones that I want to call maybe a little bit of the oddball, if you will. Because when you have a rectangular prism, you actually have 3 sets of sides that are exactly 2 of them. Think of your book. Oh, you don't have books. Never mind. Think of my book. That's a rectangle. This is a rectangular prism. Exactly. It's real thin on one side, but it has thickness to it. Now, once we start looking at a book, when you start looking at a book like this, you have a front and a back, top and a bottom, and a side and a side. And does it matter how it's sitting? No, because rectangular prisms are weird like that. Rectangular prisms don't really, it doesn't really matter what you constitute the base to be, because it's still a rectangle, and they're still so far apart, okay? So this is your oddball, like we talked with surface areas. So does it matter if I say it's a 3x2 base, or an 8x3 base, or an 8x2 base? No, it doesn't.
And the number you don't use is gonna be your height,
Correct. Or how far apart they
how
are.
far apart the bases are.
Exactly. So no matter what we use, if we say that our base is the 8x3, there are two of those, top and bottom. How far apart are they? 2. If I say it's the 3x2, there are two of those. How far apart are they? 8. If I say it's the 8x2, there are two of those. How far apart are they? 3. Rectangular prisms, it makes absolutely no difference which one you call the base, because you have 3 dimensions. No, the area of a rectangle is just length times width, or base times height, and then you multiply by how far apart are they. Well, no matter what with a rectangular one, it's always going to be 8 times 3 times 2, or 3 times 2 times 8, or 3, nope, or 2 times 8 times 3, because don't all 3 of those give me the exact same answer. Stop it. I see who's in
They're
there.
all gonna equal 48.
Yes, ma'am. What's that also?
They're all gonna equal 48.
Yeah, exactly. These are all
3
gonna,
is 24.
they're all gonna equal out to 48, but one thing you have to remember is that when you're talking about volumes, you are multiplying 3 pieces together, which means feet times feet times feet are feet cubed. Okay? Now, real easy way to remember this. How many vowels are in the word volume? 3. How many A's are in the word area?
2. 2.
See what you did there.
What changes here?
Nothing.
Nothing. Absolutely nothing. How many times have we done a hexagon-based prism? Or a hexagon perimeter problem?
2.
Only twice? Man, we should try to do it once more then. Good practice. Yes. Don't draw these. Remember, don't draw these. Because, I mean, if you can draw them, that's great. I can't draw this to save my life. And that I just find pictures and just import them because that's easier. Exactly.
Well,
Big
recording's
B
not
is
always a
one
good
half
idea, 'cause you
perimeter.
could make it right in here.
Apical. Just like every other one of these that we've done. Once you see regular polygon, you write it out, and then guess what we're going to draw? The thingy, the 3 sides of fun. Bless you. Okay? When I do that, we have done and worked with the, gentlemen, we have worked with the pentagon many, many, many times. When we find that outside angle, we take 360 divided by 5, and you get 72, which means your interior big angle would be 108. Half of it is 54. Just like every other time we have done this. What trig function is going to get you your apical? So 3 times the tangent of 54 will equal your apical. You all right with that? Now, I could figure out the value of it, or I can just leave that written like that for right now, and then just start piecing things together. Because I know that my perimeter, there are 5 sides of 6. What's that?
I was just
5 sides of 6 is how much? Okay. So, putting all this together, we have all the information we need. Like I said, volumes are really, really easy. They're so much easier and so much less work than surface areas. We know that we have the volume, area of the base, which is a 1/2 the perimeter, which is 30. Our apothem, which is 3 times the tangent of 54. And then how far apart were the bases? How far? Okay, I thought you said 4. Like, times 12. The only thing you have to be careful of if you don't find the 3 times tangent 54 right away, so you have to close the parenthesis on the 54 before you multiply by 12. That's really the only mistake that you can make. This is my exact answer. I piece it together, and I'm done. Gives me something with units cubed. So 15 times 3 tangent 54 times 12. 743.25 some cubed. Okay. Yeah. Volume of a cylinder. A cylinder is just a prism with what type of bases? Circles. So what's the area of every single circle? Pi r squared. So the formula, really, instead of writing base times the area of the base times how far apart they are, the volume of the cylinder is just going to be pi r squared times how far apart the bases are. That's it. Yes, sir. Cubed. Because remember what you're doing here. You're multiplying 3 pieces together. Feet times feet times feet would be feet to the third. Feet times feet is feet squared. So it would be feet cubed. Volumes are always cubed. I don't think that cylinders are all that crazy. I think you'll be done with them in about 4 seconds because it's quite literally putting things together. I don't know if I want to do that one yet. I tried to draw that one, it's just awful. Okay, so you have the volume of the cylinder. If we look at I thought I had this. Oh, that's right. There it is. That might not show up as cleanly. If you go back to number 9 from yesterday's homework. What's that? It's so I'm not too concerned about cylinder. I wanted to go back to this and talk about a composite volume.
I thought it just boiled down to this entire problem.
Oh, you did? We
changed
did it. We had it as 49 pi squared cubed.
Cube, yeah.
Volumes. When you're talking about volume, now obviously right now we haven't talked about pyramids yet, and we'll talk about pyramids tomorrow. When you're talking about volumes are all the stuff that fills this up. Volumes aren't the wrapping paper. Volume is
The part
it's
inside.
it's the part that on the inside that counts. That's deep stuff there.
I know.
Would you like to fill these up with water?
Yeah.
Oh, okay.
I'll do
Sure,
it.
no
I'll
problem.
do it.
Thank you.
Just a casual.
How much do I bet they leak?
Oh, perfect.
Oh yeah, would you leave the door open?
I'll just keep going.
So remember, volumes are It's what's on the inside that matters. It's on what's on the inside that counts. So when you're dealing with volumes of composite figures like this, when you have two shapes put together, do you have to back anything out? No. That's what's nice. Volumes, you don't have to back anything out. It's just all the stuff on the inside added up. Okay. So when you look at this, what we have is we have the volume of a trapezoid or a prism. That's a trapezoid plus the volume of a prism that is a rectangle. Okay? Now, yesterday I asked that you guys found the surface area of that, which means if you look back on your problem, you should have the area of your bases. So let's check this. Now, we're talking about big B is a trapezoid, so it's 1/2 the height, sum of the bases. So you had half of 2 times 2 plus 5. So big B was 7. Okay. How far apart that one is 6, which means the volume of the trapezoid part is just 7 times 6 was 42 cubic centimeters. So far, so good? All right. Now, the other one is the rectangle. Remember the shortcut for the rectangle. The rectangle, all I have to do is multiply the 3 parts together. 5 by... See? It's how much they hold.
This is a little risky.
Oh, that water's nasty.
I know. I think it's just weird.
Well, no. Now remember. I can probably say that these 2 water-holding vessels probably aren't the cleanest in the world.
Mr. Murphy, that thing's gotta go on top.
Yeah.
Would you like to try to do that?
Outside,
I'll do it.
not near me.
I'll do it.
No, whiskey we just poured on, so. Oh.
You want to try that
Spice
also?
it, no spice it.
You know what wants to float?
It's not
I'm the only one that's nervous.
I need a little bit of water out. That might actually float.
Pour it in the trash. I'll bring some.
Oh, nice. The janitors are gonna be happy about that.
Janitors
The
gonna
garbage
love
chute.
now.
Why does it wanna float?
Physics.
Congratulations.
It is kind of floating.
Now I'm just waiting for the bottom to fall out.
We need a goldfish. Have we got a goldfish?
Yeah.
Oh, well,
yes.
Let me just got one.
You want to walk quietly and dump that? I sent you on a wild goose chase. There's really no reason to do that. I just wanted to see if it helped.
Every time she leaves, I'm
Yeah, I got a goldfish, but it's dead though.
So the other one here. The other one is 3 by 5 by 6. What's 5 times 6? 30 times 3? 90. So I have 2 volumes. I have the volume of one, which was 42. The other one is 90. Right. So the overall volume of this would be 132 cubic centimeters.
Why didn't you dry them off?
So 132 cc's would be, let's see, the displacement of that. 3 cc's. That's how many? I'm trying to think of what size engine that is. It's small. It's a small engine. That's like a weed whacker engine, maybe. 100 cc, somewhere in that neighborhood. Well, actually, all right. Dirt bikes. You guys all know what a dirt bike looks like, right?
Yeah.
All right. So you get the little itty bitty 50s. You got the 100s and 125s. All right. 132 cc's is about a 125 motorcycle engine. Okay. So you start thinking about displacement sizes of pistons. That's where you're getting into. Now, mine is 1,000 cc. That's a lot bigger than that. All right. You get into some of the Harley, the big board engines like that. We're talking, you know. That's at least one.
Brandon. I run open gym. I think we have to.
Find the volume up. Hey, look, there's that missing cylinder problem. We found it.
We're doing it
The
again.
missing cylinder one. We're doing it again because some people slept through it.
Oh, that's I think we need at least 10 minutes to figure out.
He's not sure.
I just thought.
He's like, I don't know what's going on there.
Oh, stop with the there.
I'm not on this.
You're
I'm not. What's the
trying not to,
All right. Well, there's a reason that I'm doing that.
I see what you did there.
I think someone's lost it.
There's no method to my madness. All right. So this is the scary version of trying to do a cylinder volume. I know it's not that scary. It's just kind of scary. It's like when a rabbit has fangs. That's kind of scary. Not like rabbit clown.
It's cute, but oh my gosh.
Or a rabbit clown. Okay, I get it. You're gonna be bored in the middle of the summer trying to think of Murphyisms. I get it. The diameter is 16.6, which means your radius is what? So put it together, you get 8.3 squared times 5, and leave pi in your answer, and you get something cubic millimeters. All right. 1,082.12.
Yeah.
Okay. Cubic millimeters. Okay. Like I said, volumes really shouldn't take very long to do. Yes, sir.
You know how it says the okay, if I say so.
That's what my mom was asking this morning. You all right? I had some better jerseys. I think I overdosed.
Oh, he is slow.
I took a little too much and I was supposed to.
There you go. All right, ladies and gentlemen. A common design for swimming pools is that you start at one end and the depth just changes gradually to the other. Find the volume of said pool. So take a minute or so and figure it out. Use your formula sheet if you forgot certain formulas. Nope. Those are called trapezoids, ladies and gentlemen. What? Oh. This is a trapezoid.
Oh, I'm too phone class. She's a try.
Wow. Anyway, so big B is a trapezoid, which is a 1/2 the height, sum of the bases. So, the height is how far apart the two bases are, which is 36 in this case. So it's 1/2 of 36. The two bases are 4 and 12. So you get half of 36 times 16. What do you get? 288? Okay. Now, if these are my two bases, How far apart are those two trapezoids? 18. Yep. So how far apart they are is the 18. So what is 288 times 18? I can't hear what you got.
5,184.
5,184 cubic feet. Okay.
And then if this was 1990 and we were doing applied math, we would then calculate how much it would cost us to build it in a drum pool by figuring out how much the water would be shipped. And
Hey, you guys have the Google. How much? What is the volume of a gallon of water? Yes, ma'am.
Why you an ice pack?
Whoa, whoa,
Why
whoa.
you have an ice pack on?
What's that? How to get 36?
Yeah.
How far apart is the trapezoid? I got the 18 because there's two trapezoids on each
It's
side.
slick.
What does it say it is? All right, so 1 gallon is 0.134 cubic feet.
You are?
So
You are one?
divide this by 0.134.
I know I don't like it.
Okay, I don't have that money.
So it is 38,686 and a half gallons of water to fill that thing up.
Yay, save the planet.
Now, if you go to Joule and you buy a gallon of water is what, 79 cents?
Probably 98. No, 79.
Basically, if you went to Joule and bought a gallon of water, a jug at a time, you're looking at roughly over $30,000 to fill your pool. But that's not while you buy gallons of water. You would go to a pool place. They have what's called a tanker truck.
You could steal
Or a hose.
Or a faucet.
Or yes, you just go next door to the lake and you create a siphon, you suck the water out of it, you put it in your pool and it just drains.
Yeah.
Or you take
Put them in your car and drive really slow.
Really slow. Or just walk them to your house.
or you find a neighbor that you don't like
And you steal their pool.
and you hook up a garden. No, can I go ahead and say that's kind of cost inefficient?
Mr. Murphy.
What's that? You can do that piecemeal together. It'll sell.
It just comes out.
What's that?
Gotta let it go through the cycle first.
It's on your sheet. It's just base. Those, please. We'll do some more composite stuff tomorrow. I put a couple composites on there
Oh, it's time to go.
to see how you guys do on those.
That happened.